Hi, my name is Javi. I'm a senior software engineer in the mobile department here at Untitled Technology, and I would like to talk about AWS Lambda. I would like to give a small introduction on the subject and introduce serverless architectures, which is a really hot topic at the moment. I would like to talk about why they are important and what they bring to the table for cloud computing nowadays. I would like to follow with a coding example to show you how you can work with a Lambda function in AWS, how you can define a new function and test it in the cloud, and how you can build a production environment out of it. And in the end, I would like to summarize with the advantages and disadvantages of these kind of architectures and some of the points that you need to keep in mind when you're working with them. Before diving in, I would like to start with a question which is essential for cloud-native applications. Which is the question of what makes your production environment. If you need to build a new service in AWS, what are the sort of questions you need to keep in mind? What will be your environment where that service is actually going to run? There are many considerations, and the most important ones will be performance. So how do you want your application to react when the throughput is increasing or decreasing? How do you want your users, do you want the experience for your users to be affected by the increase or decrease of the throughput? Do you want to add more capacity when you actually need it, or reduce it when you don't need it anymore? Another consideration would be security. So where your application is actually running, which services can connect to that application, and which other services this application can connect to. We also go inside resiliency and availability. So you need to, if you're talking about AWS, there might be the concept of availability zones that you might want to look after. How many zones do I want to cut across? How is my service going to be vulnerable to one of these availability zones going down, etc. And in the end, you also want to talk about your deployment strategy. In this case, how do you deploy new versions of your service into production? Does it mean that you are going to have some downtime between one version and the other, or you're going to do canary releases or any other strategy, which means that you can roll out your code at the same time as the previous version being running in production? All of these have a cost associated to it. So in the end, what you're doing is solving questions related to cost. How much will it cost me to achieve this certain level of quality, this certain capacity in production for my service? If we have a look at one example of provisioning for this application, we might see the following. So you might see that you might have an application where your throughput increases steadily until it reaches a really high point, and then decreases steadily after that. For that throughput, you might want to provision enough capacity at any given point so you are not affecting your user's experience. This might look like in the slide. You might have a certain number of instances or memory to deal with the throughput in the beginning. As your throughput is increasing, you might decide to increase that capacity so you're not affecting that experience, or rather you have more resources to handle that throughput. As it decreases, you might want to ensure that some of that extra capacity is shut down or freed up so you don't pay when you are not utilizing them. In the end, what you're doing is resolving capacity decisions. So how much memory, how many instances do I need for my service at any given time? On the slide, you can see the capacity being drawn as red, which basically means those are extra resources you are paying for but not utilizing. The serverless architecture is a concept that's really a hot topic nowadays, and basically they try to tackle this wastage of resources that we have with the traditional cloud computing environment, where you provision that capacity yourself. Mike Roberts does a really good introduction on the subject, and I definitely recommend that blog article called Serverless Architectures on martinfowler.com. And the definition is as follows. Serverless basically means applications where some amount of server-side code is still written by the application developer. So you still codify your requirements as you would do in a normal environment, but unlike traditional architectures, this is run in stateless compute containers that are event-triggered, ephemeral, and fully managed by a third party. Serverless architecture also get another good definition, which is being a function as a service, and this is the key definition for how developers need to think in this new paradigm. A function as a service basically means that you write your application expecting it to handle some sort of events. You will write the function code that basically when it receives an input, you will be producing an output. In this case, you don't worry about where that service is actually going to run, just purely what it needs to do to produce an output. The containers this function is going to run on are going to be fully managed by this third party. In the case of AWS Lambda, it will be Amazon containers. These containers are a lightweight version of EC2 instances, and Amazon takes care of the full life cycle. Amazon decides where to run those services, when they need to be started up, when they need to be shut down, in order to keep your application running 24/7, but you as a developer don't really have that power anymore. Another important consequence of moving into this paradigm is that those containers are not running, as I said, 24/7. Amazon might decide to shut them down or start new ones up as your events are flowing through. This is important because it means that you cannot rely on any state on the container before your function is executed. That is what makes the compute container effectively stateless. They are also ephemeral, so between handling one event and the next one, you're not guaranteed that that function is going to run on the same container, but rather on a new one, it might not be the same, or it might be a completely new one where your function needs to run on. You as a developer, as I said, focus on the application code. So you define what is the source for the events that my application is listening to and what to do when a new event comes through. If we review the provisioning profile that we had on the previous example, it might actually look something like this. So as my throughput is increasing, Amazon might decide to create new instances to run my function. As the throughput decreases, some of those instances might be shut down, so I don't need them anymore. But this is a decision that Amazon takes care of. The developer doesn't need to know, and it doesn't really care how many containers are running at any given time, just that your function is being called for every single event or request that comes in. Now, I would like to do a small coding example to show you how you can create a function in AWS, what sort of utilities Amazon gives you to work with functions, not only create one, but also code that within the console and how to test it, and how you can basically create a production application using Lambda as its core. For the coding demo, we're going to go straight into the AWS console. Everything I'm going to do can be done from command line interface or using the SDKs. But the console is really nice to browse around and it has a few utilities I'm going to introduce later on. So let's go straight into the Lambda service, and I want to show you how to create a Lambda function. The first thing that comes up to the screen is called a blueprint, and it's effectively a solution that is already engineered to solve a particular use case. So if your use case matches one of these, you can choose a blueprint and start with that configuration already in place. So it will help you get started much faster. In our case, because I want to show you the whole process, we're going to skip this and go directly to the next stage, which is configuring the trigger. The trigger is what is going to send events to your Lambda function. So it's the event source that other applications will connect to when they want to send or fire events for your Lambda function to consume. If you click on the square box, there will be different options. These are all Amazon services that you can use to communicate with Lambda. In this case, you can choose the one that fits your use case. We're going to choose SNS because it's one of the simplest to configure. In this case, the only thing that it asks me to is to select a topic. So you must create the topic first, and then you can select the topic on this dropdown, and you can choose to enable the trigger or not when you create the Lambda function. In this case, if it's enabled, every event that arrives to that trigger will cause a new execution of your Lambda function. So if you want to create your Lambda function, test it, and then enable it, you can do that later on as well. We're going to leave it disabled and move to the next stage. In this case, we're going to configure our Lambda function. So there will be different things that we need to do. The first things are very basic. So in this case, we're going to give it a test name and a test description. And the first thing you need to choose is a runtime. There are different languages supported in Lambda. C# was the latest addition, but the others have coexisted for some time already. You can choose the language that you want to implement your function on. One thing to notice is that in the case of Java, because it needs to bootstrap the JVM, your code needs to be uploaded as a zip or a jar file. If you choose Node or Python, you can actually, if your code fits on a single file, you can edit the code directly on the console. So in this case, that's going to be really helpful for the demonstration, for the demo. But if you have other use case, you need to use Java, you can choose that one as well. So we're going to choose Python, and in this case, it allows you to edit the code in line, as I said. Your code will always be a certain function that receives an event and the context of execution of the Lambda function, and that event, depending on the trigger that I chose, will have one structure or another. So we're going to see a bit more about this later on. So we've got some previous state loaded, but essentially that is kind of like the hello world for Lambda. If we move down, you can specify environment variables. This is another new addition to Lambda, so you can specify these variables that will be available when your Lambda function runs. So there might be some use cases when this might come handy. We're going to skip it for now. The handler is is effectively the name of your function within your source code. So it's how we're telling AWS, when you receive a new event, call this particular function to handle it. The next thing will be the role. You need to give Lambda a role, as every application and services, when they run in AWS, they need to have a role that defines the permissions that application has when it communicates with other services or applications. You can choose to create one, or you can choose an existing one from the list. So in this case, I'm just choosing a random one. We're not going to create the function, as I have a few created already, but in your case, that's something that you will need to do as well. The next thing will be the memory and the timeout. So these are the only two things that relate to infrastructure that you need to deal with when you're creating your Lambda function. The memory will be how much memory my function needs when it runs for each execution. So think of it as like a bound, a limitation of for the maximum memory my function can actually consume in production. And the timeout will be how long will I want to wait for the execution before aborting. So it will be the maximum time my function is allowed to run. We're going to leave the defaults, but again, depending on your use case, you will configure these values differently. And a few other things relating to security and infrastructure that is good for you to have a read, but we're going to skip them for now, and we're just going to click next. The last part is a review of all the configurations we've chosen. So when you click create function, it will actually create this function for me to work on. As I said, we already have a few examples, so I'm going to skip this and I'm going to go directly to the Lambda functions I have created. So these are the two demo functions that I have. There is a small example I wanted to share because I wanted this demo to be slightly closer to what we might want to do in the e-commerce department. In this case, Lambda is going to act as a checkout event processor. So every checkout event from our e-commerce platform, we want to do some calculations based on the data that goes out of that event. So we want Lambda to capture every event as customers check out, and we want to do some analytics based on those events. So it's going to be very simple, but that's roughly the context for our Lambda function. And then we have two different modes of operations. So real time refers to a throughput that is roughly similar to the throughput we have in production right now. So we are going to see the events flying through the system, roughly speaking, the same as our production environment does. So it will be similar to how customers check out in Ocado. The simulated time is going to push Lambda to the limits because it's going to be firing events as fast as I can actually make it using my laptop to try to stress Lambda and see what is the limit of the scalability of Lambda, given that that's one of the biggest selling points. So we're going to see how Lambda scales and what happens when lots of events get fired. So we're going to move to one of them just to explain what is the environment you can work in. So the code, this is what we've seen during creation. So you have this function, which will do something when it receives the event. This is exactly the same as I said that we've seen during creation. Configuration will be again the options that we chose during creation. Triggers, again, this is the place you will come to if you want to enable the trigger after creation. So when it loads, you can disable or enable the trigger. And the last thing, which is perhaps the most interesting one, is monitoring. Every Lambda function will store logs in CloudWatch. So there is a stream of logs for every invocation. Every invocation of the function will write events to the CloudWatch, and you have the log stream available to you to consume and drill. Especially if you have errors, this will come in handy. The CloudWatch metrics are classified in 4 groups. So you have the invocation count, how many times can my function run, invocation duration, so how long those invocations take, and then we have errors and throttlings. Errors will be failed invocations due to an exception or an error while I'm processing the event. And the throttled invocations is a special case. It's a special case of error in AWS because you don't control the infrastructure your function runs on. Amazon will decide how many containers are going to be running Lambda functions within your account at any given time. Because Lambda can scale really fast, Amazon doesn't want this scalability to cause any problems for any of their customers. As a protective measure, so to protect their customers from sudden spikes in throughput, there is a limit on how many functions can be running concurrently, and this limit is per AWS account. It's a fair enough limit, but if your application is really data hungry, there might be many events that need to be processed, and therefore your Lambda function, you might have multiple executions of the function, and you might actually reach the limit. In this case, you can get in touch with the Amazon support, and they will be happy to diagnose. They'll be happy to speak with you about the business case and how you can improve this limitation. But all of these 4 graphs are really useful when your function is running. And there is another thing which is worth mentioning, which is the testing. So if we go back to the code, this is probably, if you're going to work with Lambda directly on the console, this is probably one of the most useful features. When you go to actions, you can actually configure the test event. And depending on the trigger that you've got, the document or the structure of the event will be different, as we mentioned earlier. So what I'm going to do is configure a test event that comes from SNS. So if I click on SNS, there will be a certain template that comes up, which has different attributes to it. In particular, there is a message within the SNS element, and this is what is going to be the event. This is what is going to be the part of the event that I'm interested in. So in this case, we can then send whichever data we want codified within the message, and then my application will read it. There are many other attributes. As you can see, there are test attributes you can add as well, and other metadata for the event that will be available when your Lambda function runs. So in this case, what we're going to do is accept that as a test event. I think it didn't save it, essentially didn't save it. So we're going to save that, and we're going to test my function with that particular event. So as you can see, when you click on test, it will actually fire a test event, and you will see the results of the execution below. There is no output, that's why it says null, and there is no outcome of the Lambda function. It doesn't return any value, but you can see the log outputs on the right hand side. Everything you print or log within the Lambda function will go to CloudWatch, as we said, and this is just a snippet showing you all of the logs that occur during that execution. So you can see event received from SNS and the event being printed, and that's exactly what happened down below. Then you can get other statistics, such as how long did it take, how much memory it actually used, etc. So for you to test your Lambda function, this is very powerful. And indeed, you can be modifying the code inline, saving, and testing, as I'm going to show you now. So let's say we wanted to get to that message that we've seen earlier. So we're going to change the code. This is just to show you how easy it is to actually prototype something in Lambda and test it directly on the console. So instead of the event, I want to print the message. I know the structure of the event is already a JSON document. So I know that within the event there is an element called records, and the first record is the one that I'm going to be reading. These records are of type SNS, and within the SNS element there is actually the message that I want to grab. So we can just save and click the test again. So in this case you can see it succeeded. I'm getting the message from my SNS event, and I've done all of this just directly from the console. So this is a really simple example, but you can already see how powerful it is. So you can be coding directly within the console, and you can be firing test events to make sure that your function works as it should. So that is everything I wanted to show from the console's perspective. Now we're going to run the application and hopefully see some of the, first of all, see it working, and then see how the data flows and if my Lambda function actually can deal with that traffic. So I have a small application ready, and this application is basically what I explained earlier. It's just a checkout stream from one of our production servers, and I want to pipe those checkout events to my Lambda function. So for that, I'm going to be using the SNS topic. So I'm going to be publishing to a topic, and that event will reach my Lambda function. So if we run, we should hopefully see a stream of events going through. The time between events is a rough estimation of how long it takes usually on our production server. So we can see already a few of these events coming through. So if I switch screens and I go to the monitoring tab, we should hopefully see the execution count and all the metrics going up. If we come back to the function, hopefully that monitoring number should be growing. Effectively, we have 5, now we have 15. So we can see that those events are coming through. We can see there are no errors, no throttlings. So my function is actually working correctly. If you click through, it will take you to CloudWatch, and within CloudWatch you can have more information about this execution, including the log output that we saw on the test execution below. So that's enough to show that indeed not only my Lambda function can work with production traffic, but that there were no errors, and it's quite a simple example, but it shows that it can basically deal with my production traffic. So now the next thing I want to do is to push Lambda to the limit. So as I explained earlier, I'm going to run in simulated time, so I'm going to ignore the delays between events, and I'm going to fire them as fast as I can make it. So I'm going to fire events as fast as I could possibly can, and let's stress Lambda, and let's see if it truly scales directly. So now we should hopefully see the events being fired much quicker than it was before. So all of these events hopefully should be reaching Lambda right now, and we're gonna see in a minute what happens. So we're gonna leave it running for a few seconds. Okay, so that's about like 10-15 seconds. Yeah, so that should be enough. So let's stop this and let's go to Lambda. Let's go to that function, and let's see what the metrics look like. So if I go to the simulated time monitoring, so we can see a completely different picture now. So the first thing is that just in a few seconds we achieve a really high number of executions. So in this case, Lambda didn't have any problems processing this volume of events, which is a really good sign. That's a sign that it does what it says on the box. So it scales really well, and we didn't have to manage that infrastructure, which is definitely a good point. There were no errors, which is another good sign, but we did get a few throttling, and this is related to what I mentioned earlier. So if you run your function and your function is running many copies in parallel, there is a limit to that scalability, and in this case we've hit that limit for this account, so it doesn't allow more than I can't remember exactly where the limit is, but there is a limit, so it doesn't allow more than X number of executions of Lambda concurrently on that account. So it will start throttling your function, and if that happens, you will see that the throttling count will go up. Again, all of these metrics are going to be available in CloudWatch, so you can just subscribe or have an application read those metrics and react upon these throttling or errors as you go forward. So after the coding example, going back to the slides, I would like to talk about the advantages and disadvantages of Lambda to give us a better understanding of with this architecture actually fits in cloud computing. Some of the advantages is that Lambda is fully managed. We get a high level of scaling without having to worry about the infrastructure, which is definitely a good benefit of this approach. We also get zero system administration. It's not exactly true that it's zero, but it's really little what we need to configure. In summary, as we've seen earlier, we just need to configure the memory limits, so how much memory each individual execution is allowed to have. What is the timeout for each execution? How long is it acceptable to wait for a response on that single execution? And which is the environment, as in the VPC or network, that my Lambda function will run on? We never talk about how many instances, how they're shut down, how to provision for higher throughput. All of that is done by Amazon, so we purely focus on the application code. The third point will be being stateless by definition. I consider this an advantage because it allows you to work purely with functions. So you focus on, given an input, what is the output I need to produce. There are no side effects, no preloaded state that can mod the execution of my function. It's really clear what the function needs to do, and it's easier to comprehend and to debug in that scenario. But not everything are good points, and there are a few points that are worth mentioning for AWS Lambda. The biggest negative, in my opinion, would be the maturity of the model. Lambda is really new. It's a concept that has been around for about 3 years now. Amazon is pushing really hard to develop new features and make AWS Lambda stand out as a choice for developers, but it has only been around for a few years, which means that the support, debugging, logging, etc., there are a few of these qualities that are still really in the early stages of development. So having said that, it's still a suitable architecture, but just something to bear in mind. It's fairly new, so dive in depending on the use case you're actually working with. Being stateless is also a negative point in my opinion, because if your function is pure, so if all the data can be derived from the input, in that case Lambda definitely fits the use case. But if to process that data you need to access other data sources or other services, then the situation becomes a bit more complicated. By caching data, you can make sure that this impact on the external data source is not as heavy as it could be, but you still need to access somewhere to get that information on each of the requests. If you could warm up data on the container and then process events from that point onwards, you will get a much better response time, and you might potentially get a better output for your users. The last point I would like to mention is startup latency. As I mentioned earlier, the containers may or may not be running when you receive a new event or request to handle, which means that Amazon might need to create these new containers ad hoc when a new event arrives. This, compared to an architecture where the systems are running 24/7, is going to have a much bigger latency when it comes to handle the events. If the service is already running, you can immediately process the event. If it's not, you need to create this container, deploy your function, and then handle it. In all, Lambda is a really good architecture. It definitely allows developers to focus on code and forget about infrastructure up to some extent. So it definitely has its use cases. It won't replace, in my opinion, platform as a service and other service offerings in cloud computing, but it's definitely one to watch. That's it from me. I hope you enjoyed the presentation. Thank you for watching.